Hello everyone and welcome to my channel about tensor networks, and this is first ever video. Today I would like to talk about how many operations does it take to multiply two matrices on the computer. And from the computer science point of view, from the algorithmic point of view, this is called matrix-matrix multiplication complexity. So let's begin with considering vector multiplication. We begin with the very simple vectors. The first vector, which is a row vector, has elements 1, 2, and 3. The second vector, which is a column vector, has elements A, B, and C. And in order to compute a scalar product, to compute a dot product, what we do, we take element-wise multiplication. So the first element with the first element, plus the second element with the second element, and plus the third element with the third element. So altogether there are 3 multiplications and 1 and 2 additions. So in total there are 5 arithmetic operations. If we want to compute a scalar product of arbitrary two vectors of the length n, how many operations should we provide? We have to do n multiplications because there are n elements between the vectors v and the w, and to sum them up we have to do n minus 1 additions. And together n multiplications and the n minus 1 additions give us 2n minus 1 arithmetical operations. This linear function, the linear growth with the size of the vectors, is denoted as a capital O of n. The next step will be to multiply matrix and the vector. There are n columns in the matrix A and there are m rows. We know how to do a row multiplication with a column. So let's use that. We know that matrix A has a m columns, which we multiply by a v vector. And we do scalar product, we do a dot product between rows of the vector A and the vector v. And there are m multiplications. So the complexity of matrix vector multiplication will be complexity of row of the matrix A multiplied by the column v m times, because there are m rows. So we multiply m by capital O of n, and it gives us O of mn. And if the matrix A is a square matrix, then people talk about n square complexity. And that's why we say that the matrix vector has n square complexity. So the next step is a matrix-matrix multiplication. As we discussed before, A is a rectangular array with the n columns and the m rows. B has a k columns and has a n rows. So we can use our previous result, split up the matrix B into k columns and provide k multiplications between matrix A and every column in the matrix B. So complexity of the matrix-matrix multiplication will be complexity of multiplicating A and the column of B k times, because there are k columns in the matrix B. So altogether, complexity of matrix-matrix multiplication will be O mn k times, which is O of m, n, and k. And when matrices A and B are square matrices, then people say about cubic complexity. And that's why matrix-matrix multiplication is said to be third order.